Hello everyone, welcome to class. Today we're looking at our last day, so day 4, week 12. Thank you again for being understanding about such short notice here. I do want to make note that this will actually be a two-part video, so make sure that you watch both part 1 and part 2. This is a longer lesson, as well as something a little bit more difficult. Now I have faith and totally you are capable of it, but know that you should watch both parts in order to get the full understanding of what we're doing here. Okay, so we're going to be looking at 5.03, which is technically tomorrow's lesson. So our goal is going to find our roots and our solutions, x-intercepts, all the same thing, remember 3 different names, by using a second method. So yesterday in class, Wednesday's class, we looked at perfect square trinomial equations. Now we're going to look at something called completing the square. Okay, so we're looking at what this really means. We've talked about this a few times now. Where what we're trying to do is we're trying to find the point or points at which the parabola is going to cross the x-axis. So this time you can see that it crosses 2 times. It crosses here, where this point is, and here where this point is. Now they have them labeled as R and S, but you can see that the y is always 0. Well, that just tells me that however I look at this, we have 2 different numbers. So this would be when we are factoring. An example of how this would look like would be x squared plus 5x plus 6, where the factors of 6 are 2 and 3. They multiply to 6 and add to 5. That would be an example of this type. The second type is if we only have one intercept, and that's where we find that perfect square trinomial, where when we multiply, we are finding it's the same number. So this would be x squared plus 6x plus 9, where 3 times 3 gives me 9, 3 plus 3 gives me 6. Well, if 3 is the same number, that tells me it only crosses one time. Then we haven't quite looked at this yet. We will. I do want you to keep it in the back of your mind. But when we're looking at this, sometimes you can't factor anything. And we've talked about this before, where you end up getting a no solution. And it's not that there is a problem with the graph, it's just that the graph doesn't touch this intercept, or the x-axis is not crossing. It's not crossing through it. It's not touching it. This also could, any of these could be the same upside down, just so you know. It doesn't change any of that. It's just whether the graph is facing up or down. You still always have that option there. Okay, so yesterday we were looking at how to solve this, and we were looking at it in equation format. So the same thing that we looked at yesterday. And we can tell the difference in each one of these by how it is lining up. So we talked about when we have just an equation that looks like it's an equation we can solve for. That's exactly what we should do. We just solve the equation. Meaning we did this yesterday. Subtract 1 from both sides. So you're left with 2t squared equals 18. And we're just step by step solving this equation. So t squared equals 9. You take the square root, and then t would equal either a positive or a negative 3. Meaning that has 2 solutions. If it has 2 solutions, then we are looking at this first example of our graph here, where it has the 2 x-intercepts. Has 2 solutions, so we're talking about 2 x-intercepts. The second type that we looked at yesterday is where we have a square, a parenthesis that's squared, as well as a number that's perfect, a perfect square number. So 9 is a perfect square because when I take the square root of it, I'm going to get a whole number. When I have that parenthesis squared, when I take the square root of it, then I end up just getting, the plain parenthesis. So if I take the square root of that, and I take the square root of the 9, and I'm left with a minus 2 equals a positive 3, and a minus 2 equals a negative 3. Remember, we have to have both the positive and the negative answer, because we don't know what's going to happen. We have to assume that this is going to cross through that x-axis 2 times. Because at this point, that's what our assumption is based on. We haven't learned how to tell the difference between whether that's going to be true or not. Then I just solve. So on this graph, we'd have a point at positive 5, and we'd have a point negative 3 plus 2 gives me a negative 1. So then we'd have a point at negative 1 and positive 5. So this graph would cross through 2 times. The last way we looked at was that we were given what appeared to be something that we could factor. And this is where I said that you can look at this and determine how many solutions it's going to have. We have a perfect square here, and this is going to end up being a perfect square because 3 times 3 gives me 9, and 3 plus 3 gives me 6. So what I have is y minus 3 squared equals 16. And then our format is now exactly like what we had in this example. So it's kind of just a review of what we did yesterday. Typically, again, like I said, people find that solving this first type of equation a little bit more simple. But don't set yourself up here. The completing the square is kind of like a math puzzle. A lot of this factoring is you're really working with these numbers and playing around with them until you find what works. Okay, so let's look at what it means to complete the square. Because that sounds kind of funny. Doesn't sound like something we really are looking into. So your goal is to find a missing number. Kind of like when we were factoring. What was that number that we were looking for that multiplied to this and add to this? So we're looking for a missing number again. And we call it a perfect, or completing the square, because 1, something's missing, so we have to complete it. And 2, we are looking for a perfect square number. Literally, we're going to square a number. So its name tells you what we're going to be doing. Okay, now this is the next step is how we do it here. Sometimes I think this is easier to just do it and watch instead. But it says square the half of the middle term. And the middle term is the one that we are looking at that doesn't have the exponent. It has the variable, but it doesn't have the exponent. So in this case, we're dealing with the bx, and sometimes we will see it as, if you're looking at it, if you're looking at this top one, this is an expression, and then this is an equal sign. It's ultimately the same thing. One's an expression, one's an equation. Sometimes you will just see it where there's a number. Okay, so what we need to do is find the number that's going to fit on my blank in both cases, meaning there's a number that's going to be missing here, and we need to figure out what it is. Well, we do that by taking half of b. So we're going to do b divided by 2, but then we square it. If you are dealing with an equation, I can't just add something to one side and not the other. So we actually will need to ultimately add it to both sides if you have an equation. If you have an expression, it doesn't matter because there is no equal side. We're not trying to work on keeping things balanced. It's only when we get to that equal sign that we need to think about that. Okay, so let's look at this and actually put it into terms of a problem. You will know you have to complete the square when you are missing a number. We have been looking at trinomials for the last few weeks here, and you can see that these are trinomials. We literally have something that should go here, and it doesn't. That's a problem. That's why we do this. So we need to look at for the term that doesn't have the exponent squared on it. So it has a variable, but it's not squared. And in this case, we're looking at that 6x. That means I need to do 6 divided by 2, or take half of 6. Half of 6, or 6 divided by 2, still gives me that 3. But I need to square that. So 3 squared, and I get 9. That tells me the number I'm going to add on, that number that is going to complete that perfect square, is a positive 9. This should also, when we are ultimately finished here, this type of formula should look really familiar to you. And that's because we've looked at this perfect square trinomial many times. Our goal is, like I said, to get a perfect square. Well, 3 times 3 gives me 9. 3 plus 3 gives me 6. This is a perfect square trinomial. It's the same number that's being repeated. All right, so let's try the next one then. All right, So now we're going to look at that bottom one, or the middle one. So I have x squared minus 8. So I'm going to take that negative 8, I'm going to take half of it, or divide it by 2. It's the same thing, however you want to look at it. Negative 8 divided by 2, and I get a negative 4. Negative 4 squared, and I get positive 16. That tells me I add my 16. That's the number that's going to complete the square. Think about it. 4 times 4 gives me 16. 4 plus 4 gives me 8. So we're just looking for that number. The number that's going to complete the square, the number that we have here and here, this is the number that if I made it into a parenthesis, that's what I would be factoring. That's how I find that number. It's a little bit faster, instead of guessing and checking or making a table, to divide it by 2, multiply it by a half, and square it, right? That is a efficiency thing in math here. Said it before, I'll say it again. Mathematicians are lazy. We look for fast ways all the time. Alright, so let's look at our last one here. So I'm going to take that negative 7. I'm going to take half of it. Now this is where it comes into play. Every time we take a half of an odd number, we're dealing with decimals and fractions, and it becomes a pain. That being said, yes, I pull up my calculator when I don't want to find out what negative 3.5 times negative 3.5 is, sorry. And I get 12.5. So that would tell me that, in this case, the number here is a positive 12.5. You will always be adding a positive number. The reason you will always be adding a positive number is because when you square something, even if it started off negative, it is now becoming positive. If I wanted to figure out what should go in those parentheses, if that's what I were looking for, there you go. I already found that number. I already found what the answer should be. Okay, so we're just finishing up on our first video here. So really what we've looked at so far is two things. Ultimately, the goal is to try to figure out, again, where does this cross the y-axis, or the x-axis, excuse me. And all the ones that we are going to be looking at are either going to be crossing 2 times or 1 time. We have not gotten to the point yet where you will continuously see a no solution option. So your first mystery number today is going to be, how about 76? 76 will be your first mystery number. And then watch the next video that I sent on the link, and then it'll finish up how to actually complete the square. Because so far we've only looked for the number. We haven't looked at changing it to be in equation form yet. So look for the video. Should be the link right below.